thankful to uh, uh, Raman Naik sir and Srinivas Reddy sir to inviting me this talk. And mine is relevant to some kind of a uh, technology-oriented talk. In addition to what previous speakers spoken about the condition assessment or repairs and retrofitting of the structures. And this presentation prepared basically from the research articles as well as Google. Some of the pics are taken, and don't mind that. And we just initiated our research work, our university. For that, I could not produce giving my own research in this presentation. But what is happening around the world, which is relevant to the current scenario, we can use this technology for the speed up our construction, retrofitting and repair of the structures. Not only buildings, but also bridges, maybe roads, dams, all kind of infrastructure, even telecommunication towers also. So this technology will help us to more effectively, efficiently. You can see this one. I just start with this. Nowadays, everybody use these analog watches as well as digital watch. Nowadays, everybody, all young generation, even like our all age people nowadays, going for the digital approach, digital smart watches, right? So, what is the use of this one? It improve our it has more number of features, right? But primary goal is to both analog watch and digital watch is same is to know about time. That is the primary focus, primary goal of these kind of watches. At the same time, in the condition assessment is concerned, we do the visual process, visual inspection, right? As well as nowadays we use a technology, drone. But what is the goal of both is to again to quickly and safely assess the condition of the structure, defects, monitoring and maintenance. Both goal is same. One is slow rate, another is a faster rate. That's the only difference from this technology is concerned. But what are the rest of the things which is what we are using, procedure for assessing the condition of the structure, maybe repair, rehabilitation, remains same. Only except the first stage of the conventional process to the technology. So this technology we need to be understand. You should know because this is as I said. Maybe young engineers who are like my age or who are young budding engineers, definitely this is another green field for more job opportunity or career kind of things where these things will change, the market will be emerging to civil engineering field. So every industries adopt this technology for their own infrastructure. Maybe nowadays you can see the high-rise buildings or even industrial buildings also. So they can buy a drone, they can fly it, they can get the data, they can monitor every day. Every day they can check it previous to this to next, maybe before repair, after repair and everything, right? So this technology cannot be replace the engineer. Only it's empowering the engineers. That's only quotation I can say that, but through understanding about this technology, we need to adapt like a smartwatch. So why to study about this one is more about the rapid growth of civil engineering infrastructure, demand affecting the periodic infection compulsory, like Medigada barrage, like other structures. There are millions of such structures are there across the country. And also environmental exposure and overloading accelerate the structural deterioration, increasing the risk of failure. This must be addressed. And advanced inspection techniques are essential to ensure the safety and serviceability life. This is a general perspective of do the condition assessment. But if you want more faster, more smarter way to assess and give the report, take the decision, immediately do the repair and retrofitting of the structure. So what is the background of this study I took, and this is a major concern which are failed because of the poor maintenance and the inadequate checkings. So this is a major concern. Maybe if you have a drone, I can fly it, I can get within 1 hour or within 10 minutes. But if you do the manual inspection for this kind of structure, it takes 1 day to 2 days and 3 days. Sometimes it is inaccessible also. I cannot do the inspection during the monsoon because the river flow, continuous water flow is there. But however, I can use this technology, definitely I can do it and get the information and give the further processing. And this is also another kind of buildings also failed recent time. This is also a problem with the maintenance and structural stability issues. You can see some of the statistics Indian infrastructure, but this I taken from ChatGPT, don't mind. But this is not the actual results, but this is approximate result. But this is only alarm for us why this technology or by why condition assessment is required current generation. As previous speaker, Srinivas Reddy sir also emphasized on importance of this retrofitting rehabilitation of the structures. Okay, let us look into that. 1,63,000 maybe plus public infrastructure assets, railway bridges, national highway bridges, dams are there. Around 1,600 plus tunnels across India, railways, roads and hydropowers. Total around 327 railway tunnels are there. 5 lakhs plus large dams, 487 airports. Indian road network like 6.62 million kilometers. So this is what most important for us to know about the cracks or pathholes for the any kind of a state highways, national highways are concerned. So you must monitor these state highways, national highways also, those technology. And also the other is RC buildings. It's a no information. It's a millions of buildings which are already existed, which are deteriorated, which are existed by 50 years old, 40 years old, 20 years old, 10 years old. But these are questionable whether it is safe or not. We don't know that. But there is immediate attention for these conditions, assessment, as well as you have to give some rating to this kind of a structure to using this technology, right? But in a simple term, condition assessment is a inspecting, evaluating, document the current health of the safety, performing, and also check the defects, deterioration requirement. Basically, you can answer these basic 3 questions for any kind of a structure you are looking. So one is a present condition of the structure, what damages already, defects existing, and what action to be required. This is the usual process we do the condition assessment. So let us see this. These are step-by-step procedures generally we adopted in general, but where the drone technology will be entering to this step process. This is the first step. The first step, generally any infrastructure we can do is a visual inspection. So that will take a lot of time and is inaccessible, but using this technology, I can get the data very quickly and I can access to anywhere in the structure. Maybe I can go around the structure, inside the structure like that. But some of the structures also limitation. But this is where one of the key parameters added to our life like a smart way of doing the condition assessment. And traditional versus drone technology, I told you that if you do the traditional versus assessment of the building, then we need this kind of a instrument, mechanical instrument like vehicles, maybe ladders, maybe scaffolding, something like that. But this will take a lot of cost and money and empower and take a lot of time to assess the visual inspection. But if using this technology, I can get immediately, quickly, this high resolution image, as well as 3D model, orthomosaic, as well as complete information about the building, which generally we missed in the visual inspection. Okay, but this terminology may be different, this is new to everybody, but definitely slowly we need to understand it, which is required for all civil engineer to know about this technology. So maybe this traditional versus drone inspection, the cost-wise, low cost, and safety is most important. If you do the manual process, safety is a concern. Maybe we cannot go for the hazardous areas like collapsed structure, but whereas drone can go and inspect and come back the data. So it has a limited to by physical constraint, landslides, we cannot go, but whereas drone can go and fly it, get the information. So these are some of the area we can use it, but nowadays everywhere we are using the drone technology, and especially looking to the guidelines for the evaluation of the IRC SP 37/2020. So there we need to do every year post maintenance and inspection of the report need to submit by the to the chief engineer office. So this is where we need to do a periodic maintenance and periodic inspection for the bridges. So there it is helping for our like cracking, spalling, or corrosion of the rebar, any kind of things are existed, effective and conditional structural joints, expansion joint. So everything you can watch it, just fly this kind of a drone technology. Okay, these are the buildings, state highways payment is concerned. So you can also be fly it by using this technology. We can get all the information. Any cracks are existing in state highways, potholes are existed, and any holes are there, any orientation, alignment of the road, we can also quickly get it and give the rating for these payment. So do the further assessment or giving the guidelines to the retrofitting repair of the structure. Similarly, buildings also. I just skip this one. Okay. So this is a UA technology where people are using nowadays. It's entering every field of the engineering. So you can see the buildings, you can see the energy sector like power line, wind turbines, photo plants, pipelines, bridges, pavements, sky rails, railways, maybe water tanks, dams, and ports also. So everywhere we need this technology. Like we are converting the analog watch to the digital watch. So we need to take about this advantage of this digital technology. Okay, I just skip this one. This also you can see. It is also helping to floods. During the floods, after the post-event of floods also, you can know about what is the areas, how much area is flooded, if any buildings are collapsed due to the floods. That also you can get the information from this drone technology. We can use nowadays for the smart traffic monitoring, land mappings and surveying, as well as mining. Also you can check it through this technology, faster rate, how much they are digging, how much depth they are, volume of the mining is taking place. So those kind of study also we can do using this drone technology. So what is drone technology? I just will take another 2 to 3 minutes basically. But this is like a digital watch. You should know about what is a digital watch, procedure to how to use a digital watch. Similarly, to this drone technology also you need to know about what are its component, what is the process of getting the data, analyzing the data, final outcome what we want to engineer, that we need to ensure it. Okay. So here, so drone is a simple term, is an aircraft operated by without human, onboard controlled remotely, autonomously, like this. You can see this one. So this person is not sitting into the drone, but he is standing and flying the drone. So that's main difference from aircraft to the unmanned air vehicle system. So it has a consisting of GPS, camera, sensor, and so on. So these are some components to fit it. So aeroplane is a like simple human pilot is required to fly this. So that's main difference from the drone to the aeroplane. Right? So these are some of the differences you can find cost-wise, but this drone is one advantage that often no runway is required. It can fly anywhere, any place compared to the flight. So there are different types of drones which are existed in the market. So we can use it for different purpose. So which are fixed wing and rotary wings and hybrid drones. As you can see, this kind of rotary wings are majorly used for all major infrastructure. Fixed wing type hybrid drone for the military application, even civil engineering application for surveying, mapping, and for large areas we can use for the fixed wing as well as hybrid drone. For this case, for fixed wing drone we require a airfield to fly, but whereas a rotary wing we don't require any airfield. You can fly and it will take vertical takeoff, and moving horizontally, vertically, you will stand in the air. Whereas a hybrid drone, it cannot, even fixed wing drone, we cannot. But this is some of the drones, we can use it, different applications in the engineering. But whereas fixed wing drones, hybrid drone used for the long run ranged area, because you want collect the data, it may take 1 hour to 2 hours. So that we can use for the fixed wing drone. Whereas a rotary type drone, we can use for this small, because it is a endurance limit is only 20 to 30 minutes. It's half an hour. So it's a limitation, battery limitation. So we cannot use for the long range works. So we can use for fixed wing or hybrid drones. So these are types of drones used across the globe. Majorly infrastructure used for the rotary type things are 89% compared to the fixed wing drone as well as other type of drone. So generally, you can see these are different classification available in the drone markets. So nano, that's where the people are using playing the game, and they can use for the functions, maybe marriages, and micro and small. So these small drones we can use for our infrastructure. Even medium drone, where nowadays we want to use carry the cement bag to flying from one point to the other point, we can use a medium range drone. So this technology is already used in the Chinese and adopted. So since maybe it is also entering to the civil engineering domain in the Indian context, so we should be trained, we should have certified to use this kind of a drone, medium range drone. That is a capacity of 25 kg to 150 kg it can carry. So that's 1 kg of cement, 2 kg of, 50 kg to 150 kg of 3 bags of cement it is to carry out by using this medium range type drone. But for inspection, we can use a small type of drone which is carrying the payload of the 2 kg to 25 kg. So you can carry like a agricultural drone comes under the small range drone based on the payload condition. So these are the basic components of the drone. If you are interested as engineers, so you can play and plug it. You can fly the drone also. It's not a compulsory to somebody to prepare and fly it. Yes, it's all assembles are available in the market. You can play and plug it. So every software is also available. Okay. So these are some of the components generally we can use it for preparing the drone. Frame, motor, flight controller like a brain, sensor, GPS, RTK modules, camera, telemetry, battery, camera, lidars, gimbals. So these are the basic components of the drones. We can prepare and use it. So just skip this one. Majorly we can use for capturing the information as the RGB camera as well as lidar. These are two cameras which are required to get the full information about the structure. If you want to know the crack of the structure, I can use a lidar camera is sufficient. So, but I want to know the depth of the maybe like a know the embankment excavation, I can use a lidar. So the application is little different usage of this camera as well as a lidar concept. So these are the flying drone. So one of the important for the flying this drone is drone planning and mission planner. So where to fly, how to fly, you have to fix it and you have to move according to these lines. So you can see the green lines. So you can starting point, ending point. So you need to arrange it. First you open the map, you can fix your planning. So any obstacles are there, like trees are there, buildings are there, you have to ensure, go to the site, you have to check it, and then you can fly it. So this is most important for the mission plan. After the mission plan is over, so you can fly the drone along these grid lines and get the data. But whenever extracting the data, you are achieving the overlapping 70 to 80%, you will get the accuracy of the result. So there is another key point is important for drone is a GPS, because we want accurate coordinate. So that coordinate will submit to the government for tendering project, any other project. We require a GPS location. Then this GPS RTK, where you are getting the exact location of the GPS from the satellite. So they can install the rover. From that rover, they are fixing the GPS coordinate. So with respect to the GPS coordinate, I can measure the whatever the area coordinates are required for with respect to that location. So that anybody can use it globally, locally, for any government department. They will ask this RTK data acquisition also for getting the GPS coordinates. And these are drone data processing. Once you assemble, you can fly it, you are ready to fly it. So you can do the getting the data. So the basic components of these drone data processing are, first thing is a flight parameters. So you have to understanding about the drone. So ground sampling distance, area of interest, camera information, flight Google. So when you start something, you have all the things you need to be check it. So another mission plan. So UA platform, autopilots, ground control station. And also once this is over, so ready to fly it, and you get the image from the, or you can record through the video or the images. So once you get the images, you have to do the images, you are processing the images and resize it and correct the sampling data, and then you have to finally you are extracting for the DTM DSM generation model. With respect to that, you will get the ortho images, 3D model. These are very, very important outcome of this drone technology. So just on, these are some software to extracting this data, giving this ortho mosaic and 3D point images like this. So these are the fixed 4D AGI soft can use it for the extracting data. Once you flying this drone, you will get this data and feed into this software. You will get this kind of outcomes like this. This orthophotic map. So this one is geometrical correctable area of photography or satellite image through the drone. Maybe general satellite you will get the one image, but this is I can say locally where you flight area you will get. So you have to get the final area of that map. Right? So from this you also get you want to know about the coordinates and location, three-dimensional system. We have to get the use of point clouds software. You will get all 3 dimensions, and from that you can create the existing infrastructure which before the drone, then after the drone. So you can see all the features of the drone, the images, buildings or infrastructures are concerned. So these are some of the outcomes for application. I just skip this one. So this is the outcome you can see from your drone. So these are 3D mesh of the drone after point clouds and the automobile pose image. So how drones you are flying, the flight plan also you can see the round one, around the building so flight can fly step by step. So you can round one circle, move complete, take another 1 meter depth height, round again, take 1 meter, like that you can take the different levels, fix it, and according to that you have to be fly it and get the maximum information from this technology. And there is a rules and regulations of the drone. So this is most important. Yes, everybody can buy it, everybody can use it, but there is a cautious, just like a license. So when you buy a car, so you must get the number plate, number of the car, as well as and your license. Without license, without number plate, you cannot use it, that car, maybe police will come. Similarly, there is a, if you buy a drone, buy a flight, so you must be registered for the drone as well as you should be licensed it. So without that, you cannot fly it. So here, these are drone rules also acted by this DGCA in the year of 2021. And this one, and these are some of the things which are important, like you cannot fly your wish. There is a constraints, there is a permission to take to fly this drone. I cannot fly like in this place because it comes under red zone. But I can fly outskirts of the ORR. It comes under green zone. So this is how you need to be looking into that. Whenever you're flying a drone, you must see where you are flying, which comes under red zone, green zone, or yellow zone. So green zone, we can fly it. Red zone, yellow zone, you take the permission from the DGCA, which is the Airport Authority of India, as well as the Indian government. So depend. Okay. So this is a portal for that, whether your site is located to the green zone or yellow zone to fly these drones. So this is a UN number. You have to get the certificate from the DGCA, as well as you should be pilot. You should have pilot license. You have to get from that. So some of the case study. So this I am giving the glimpse of the how this drone technology used for the multi-story building. Previously, people are done for the bridges, but this can use for nowadays. People are attempt to understanding this UI technology, extracting the data. Finally, outcome is a cracks as well as maybe seepages and leakages. Anything is identified. Those three technology. Okay, closing. This is what the outcome of this. They tried. One of the paper was tried to experimenting the building cracks, but this will only giving them physical visual inspection effects only, not the structural point. You have to go to do the NDT, other kind of things we need to be do it for this, getting the full level of the assessment of the building. So it has some limitation for the drone inspection. So it's major influence weather condition, which is one concern. You cannot fly for the heavy wind speed or heavy rains. Another one is a regulatory requirement. So you have to follow the drone regulations and initial investment. So little investment is there, but it's a thank you.